Hello everyone, myself Namrata Thakur, Senior Lecturer in the Department of Computer Engineering, Shift A at Pravin Patil Polytechnic, Bhinder East. Today we are going to learn the third chapter of OS, Process Management. There are total 3 videos, part 1, part 2 and part 3 of the third chapter. So let's start the first video of the third chapter. Students, from this entire video, you will able to understand the concept of process along with its different states, what exactly you mean by PCB and what is the meaning of context switching. So let's start each and every concept in detail. The first question comes in your mind what exactly the process is. We have already learned the concept called as a process management in the second chapter of the OS. Process is any program which is in execution. Program means what? Students, you have already learned or you have already write the different program in C, Java, HTML, etc. Suppose I have given you an assignment, write a program to add two numbers in a C. What you people will do? You will write some set of instruction for the same. This set of instruction is a program and you will save this program in a C drive or D drive with .c extension. So this concept is all about the program. But whenever you are using the control F9, that means whenever you are loading the program in the memory for the execution, it becomes a process. So therefore, process is any program which is in execution. Take another example. Suppose you are playing a game called as a Road Rash. The Road Rash is already installed in your PC which gets stored in a C drive or D drive. You are double clicking on it to open it. Once you double click on it, it gets loaded in the memory for the execution. Here your program called as a game become a process. So whenever the program is loaded into the memory, it become a process. Not necessarily user program is a process. You can say any internal task of the CPU as a process or any entity which represent the basic unit of work is a process. Now, let me tell you the difference between the process and the program. So let's start the difference with the help of definition. Process is any program which is in execution, whereas program is a set of instructions to do the particular task. Process is an active entity. Why it is called as active entity? Because whenever the program is in memory for the execution, the program is executing. Therefore, process is an active entity, whereas program is a passive entity because you are just saving the program in your secondary storage like hard disk, CD, pen drive, etc. Therefore, it becomes a passive entity. Process is a part of program. If program is not there, there is no question of process then. Therefore, process is a part of the program. But program never be a part of process. Process, where exactly we are going to store the process, but obvious in the memory because we are loading the program in the memory for the execution. So process get load in the memory or process gets stored in the memory for the execution. Whereas the program gets stored. Students, where you are storing your game, otherwise any files, but obvious in a C drive, D drive of your hard disk, otherwise pen drive, otherwise CD-ROM. Therefore, program gets stored on the secondary storage device. The next one is process state. The state is current activity of anything. If I am saying that process state, then it becomes a current activity of the process. take general example. Now you people are watching this video. So watching is your current activity. Therefore watching is your state. Similar way, whenever the process is executing, at that time process always change its current activity and that become a state. So a process passes through the different state as it executes. Processes varies from system process to the user process. There are total 5 processes in a 5 process state. First one is a new, ready, third one is a waiting, after that running, and after that terminated or exit. Let me tell you the definition of each state and after that I will come to this diagram. The first state is new. In the new state, the process has just created. Whenever the new process is just being created, you just click on the road rash game icon. So it becomes a new state. Running. If the process is currently being executed, that means if execution is going on at that time, it's in a running state. Ready means suppose the process has just created and it is waiting for the opportunity to being executed. If opportunity is given to it, it will get executed. It enters into the ready state. If all final successful completion is done, that means if process finishes execution, it will enter into the terminated state. And the last one is waiting state. If your process is waiting for some IO devices or some event to be occurred, at that time it will enter into the waiting state. I am giving you one general example. Suppose I have informed you tomorrow is the OS submission. What you people will do? You will start writing the manual. So your starting is a new state. Once your manual is completed, at that time you are in a ready state. That means if I call your roll number, you people come to me and I will start doing the submission. So you are ready for the execution if opportunity is given to you. The third one is running. If I'm checking your manual and if I'm giving you the mark, that means the current execution is going on. So you are entering into the running state over there. Now, the next one is terminated. If or exit state. If I have checked your complete manual without any mistake, if I am giving you the mark and after that I will take the final submission, that means you people entered into the exit state. The last one is waiting state. While doing the submission, if any error occur, if I said your manual is incomplete, complete this particular answer. At that time, you people will be in a waiting state, or I can say that suppose some interrupt occur while I am doing the submission. At that time, you people are waiting when miss will become a free. So you people will go in a waiting state. So this is all about the state. Now let's check this diagram in detail. The first state is new. In this, a new process is just created. Once the opportunity is given to it, it will admit into the ready state. In ready state, processes are ready for the execution. Therefore, it will dispatch. If opportunity is given to it, it will go into the running state. Here, the actual execution is going on. If successful execution is there, then it will goes into the terminated or exit state. This is the normal flow for any process execution, that is new, ready, running, and after that the terminated. In case if the process is in a ready state and if the process is in a running state and if any error occur or any event occur, the process will move into the waiting state. And after completion of that input output device or event, it will again go to the ready state. After that, it will again go to the running state, and after running, it will go into the terminated state. Therefore, every time the process has followed new, ready, running and terminated state. This is all about the process state. Now, the next concept is process control block. Process control block is PCB. It is also known as a task control block or process descriptor. Student, if I am saying that process management is the activity of managing all the processes, process is a program in a execution, but obvious the question will comes in your mind where exactly the operating system or the computer system store the information related to the process. The information related to the process will get stored in one block and that block is your PCB. So, PCB is a data structure used by the computer OS to store all the information about the process. For example, suppose student information is get stored in a college student database. What information it will store? Student ID, student roll number, student enrollment number, name, address, marks, parents number, their mobile number. So all this information it gets stored in a one file. Same way, process related information, for example, process ID, process name, process timing, all this information gets stored in a one block and that block is a process control block. This block is get created in your system when process is get created and it will get terminated when when process get terminated. Therefore, each and every process has its own PCB. It will get created, PCB will get created when process created and PCB will get terminated when process terminated. Therefore, PCB is a data structure to store or PCB is one platform, one media where you can store or I can say that one storage where you can store the different information related to the process. But what different information it will store? So information associated with each process is process state as we have discussed before. What are the different states? New, ready, running, waiting and exit or terminated. And PCB is responsible for storing all the information related to the process. So as shown in this diagram, PCB store process state, process number, program counter, register, memory limit, list of open file, etc. Therefore, the information associated with each process is process state, that is new, ready, running, waiting, program counter. Program counter is used to store the address of next instruction which is to be executed in the system. Register CPU scheduling information which process should be executed next and the memory management information. How much memory required for the process, how much memory is allocated to the process, all this information is get stored in a PCB as well as the input output status information is also, suppose process requires some input output devices, so all this information gets stored in a PCB. Therefore, PCB is one media, one data structure where you can store all this information and all this information. The last topic for this video is context switching. Let me tell you one general example. Suppose I am doing submission of the OS and roll number 1 submission is going on. There are total 14 experiments and I have checked or I am starting the submission, I am starting the checking and first experiment get completed. After that I will move to the next experiment, experiment number 2. I have given the marks of 2, 3 and 4 experiments. While the fifth one is going on, while the checking of fifth experiment is going on, some interrupt occurred and I have stopped my work. Some interrupt means what? Suppose roll number 1 submission is going on. At that time, roll number 30 comes in and he or she said, Miss, I'm having some urgency, I have to go early, therefore do my submission. That means interrupt occur over here in my ongoing process, or highest priority I am giving to that roll number 30. Therefore, what I will do over here, I will stop submission of roll number 1. That means I have already checked the 4 experiment, and the fifth one is going on. So I will stop that roll number 1 submission, and I will move to the roll number 30 submission. So I will start checking roll number 30 manual. After checking the manual of roll number 30, after the whole completion of manual or a whole checking of roll number 30, I will again move, or I will again start the roll number 1 checking. That means what? Here I am basically moving from one state or one state to the another state, or one contest to the another contest. Okay, therefore see here, after coming to the roll number 1, after coming to roll number 1 submission, I will not start checking the roll number, experiment number 1, 2 and 3, 4. I will directly start from the roll number experiment number 5. Why? Because my operating system will save the old context or the information related to the old process as well as the new process. What I will do in my file, I will write the record that I have already checked 4 experiment of roll number 1 and all the 14 experiment of roll number 30. So after switching from roll number 30 to roll number 1, I will start directly the fifth experiment of roll number 1. So here I am saving the context of one process and loading the context of the another process. Context means that area or that particular thing. So therefore, whenever process execution is going on and such situation occurs, some highest priority process comes, any interrupt occur or preemptive CPU scheduling is required. At that time, my CPU will stop the ongoing execution of current process and it will move to the highest priority process. Same way, I have switched from roll number 1 ka submission to roll number 30 submission. And after completion of roll number 30, I am switching to the roll number 1. So this is called as a context switching. Whenever process execution is going on and if interrupt occur, this situation only happen when interrupt occur, when highest priority process come. At that time, CPU will stop the ongoing process execution and it will switch to the new process. But while switching, it will save the context of one process. Similar way, I have also recorded first 4 experiment marks in my file of roll number 1. Same way, it will save the context of one process and it will load the context of other process. That whole process is called as a context switching. It is required when switches to the another process. CPU switches to the another process. But obvious it is very time consuming and the hardware support switching in a computer always require a good quality of hardware, and it is very overhead to the system because sometimes we can't do the useful work while switching. This is all about the context switching. So here I have represented this concept using the diagram. That is, the process P0 is executing. At that time, process P1 is ideal. Now, if interrupt occur, then at that time it will save the state of first P0 process in the PCB, because PCB is responsible for storing all the information related to the process, and it will reload the process called as a P1. Reload means what? It will load all the information related to the P1. And once the interrupt has completed, it will save the state into the PCB1 and reload the PCB0. That means it is saving the old context and reloading the new context of the process. So this is all about the context switching. Thank you everyone. If you have any doubt, let me know. Post it into the comment box. I will surely help you to solve the same. Thank you.